So matter can be mainly classified into pure substance and mixture on the basis of this question. Can it be physically separated or not? If that substance can be physically separated, we can call it as mixtures, and if we can't separate that substance physically, we can call it as pure substance. And again, if the pure substance can be chemically decomposed, then we can call it as compound, and if we can't do that chemical decomposition, we can call it as elements. Okay. And when we come into the case of mixtures, if the composition of this mixture is, whether this composition is uniform, we can call it as homogeneous mixtures, that is solutions. If the composition is not uniform, we can call it as heterogeneous mixtures. In that category, we can have colloid and suspension. So this is all about the classification of mixture. Okay. So if you want to note this one, you can note. Okay. Now I am rubbing this one. So now we will deal about this homogeneous mixtures and heterogeneous mixture. So we can start from this homogeneous mixture, that is solution. Okay. So first topic is solution. So what is a solution? It is actually a homogeneous mixture of substances, right? It is actually a homogeneous mixture. It is actually a homogeneous mixture. Homogeneous mixture. That is, its composition is uniform. Uniform composition. And the examples for the solution is salt solution, sugar solution, like that. Okay. So we can say that the particle size of the solution is less than 1 nanometer. That means maximum particle size is 1 nanometer. And we can have less than 1 nanometer having substances. The particle size must be less than 1 nanometer. Okay. So the particle size of the solution is less than 1 nanometer. Okay. So it will be less than 1 nanometer. That means maximum size of the particle is 1 nanometer. Okay. Then we can prepare when we take the case of solution, it can be 3 types. Okay. So first one is liquid solutions, gaseous solutions, and solid solution. So we said that solution is having homogeneity, right? That means uniform composition. So we can say that it have homogeneity. Okay. So that means the particle size is same throughout the solution. So we can't distinguish the particle by naked eyes. That means the particle size is less than 1 nanometer. So we can't see the particles through naked eyes. We can't see particles by naked eye due to the less size of particle. Okay. And when we take the case of solution, it can be liquid solution, gaseous solutions, or solid solution. So when we take this case of liquid solution, the examples are salt solution, sugar solution, like that. Okay. When we take the case of gaseous solutions, its example is air. Okay. So similarly, when we take the case of solid solution, the examples are alloys. Okay. Examples are alloys. Example is brass. Okay. So these are the main thing about this solutions. Okay. So the solution can be liquid solutions, gaseous solutions, or solid solution. And due to the less particle size, we can't see particle by naked eyes. Okay. And along with that, if you have noted these points, I am rubbing now. We want to add more points to this. Okay. So this is homogeneous mixture. Okay. So due to the less size of particle, if we are passing some beam of light through the solution, it won't scatter the beam of light. Okay. So we can't see the beam of light through the solution. Okay. If we are passing beam of light, it is not visible. It is not visible or invisible. Okay. When that beam of light is passing through the solution due to the less size of particle, that is the particle size is less than 1 nanometer, right? So due to this less size of particle, when we are passing beam of light through the solution, what will happen? We can't see the beam of light. We can't see that light when it is passing through the solution due to the less size of particle. Okay. So that's all about the solution. Okay. So we can say that if you have noted these points, I am going to rub this one. So we can say that a solution can be prepared by adding solute to the solvent. A solution can be prepared by adding solute to the solvent. Okay. So then what is the solute and what is the solvent? A solvent is a component within the solution which is used to dissolve the other component. Okay. So what is the solvent? It is a component within the solution which is used to dissolve the other part of the or other component of the solution. It is a component which is used to dissolve the other component of solution. Okay. So its amount will be within the solution, the amount of solvent will be larger. The amount of solvent within the solution is larger. The amount is larger. Okay. So similarly, when we take the case of solute, what is solute? The component, here we are saying that it is a component which is used to dissolve the other component, right? So that component which is dissolving in the solvent is called solute. The component which is dissolving in solvent is called solute. And the amount of solute will be less. The amount of solute will be less. Okay, so we can say that a solution is prepared by the combination of solute and solvent, and the solvent is more amount and the solute is less amount. In the case of solution, the amount of solute is less. Here this is less, this is more. Okay, or large. So this is about the components within the solution. Okay, so if we are taking, I am rubbing this one. If you want to note, you can note. So if you are taking a solution over here, solute and solvent. Okay. So first case is salt solution. So what is the solute particle of the salt solution? That is salt, right? And its state is solid. Its physical state is solid. What about the solvent? Solvent in the salt solution is water and it is liquid It's in liquid state. And this is an example for liquid solution, right? And similarly, when we take tincture of iodine, tincture of iodine. Tincture of iodine means it's a solution of iodine and alcohol. The solute will be iodine. It is in solid state, and alcohol. It's in liquid state. And about the third case, air. When we take the case of air, so it's an example for gaseous solutions, right? So what is the solute particle? Solute particle is oxygen. That means 20% of oxygen. And nitrogen will be 80%. And these two components are in gaseous state. So this is an example for gaseous solution. Similarly, when we take brass, it is an example for solid solution. So in this we have